Hello again, I'm Anna Felina with a series on solid principles. In this first part, we'll explore everything about the single responsibility principle. We'll look at existing code. We will refactor it to ensure that we respect this principle. We'll then look at the advantages that this refactoring brought us. The code that we'll look at is a transaction controller. The class has 4 methods. The first creates a transaction as part of a multi-step checkout process. The second charges a credit card through a payment gateway. The third emails a receipt to the buyer, and the last one enables admins to refund the money. This class is using a number of services. First, we have a database connection. This gives us access to functions such as creating and fetching database records. Next is an HTTP client, which is used to send requests to the API of our payment gateway. It is through these requests that we charge credit cards and refund payments. There's also a library used to create PDF documents, which is how we generate receipts before sending them as attachments via email. Finally, the mailer is a library to actually email these receipts. All of these are public libraries that we installed using Composer. We get these libraries into our controller through the constructor and assign them to the private properties. This approach of getting services into our classes is called dependency inversion and is another solid principle that I'll cover in the 5th part of this series. Here's the create method of that class. It's called when the user decides to check out the shopping cart. The first thing that we do is grab the JSON body of the request and parse it into an array. We then insert a database record for the transaction by supplying the user ID. For each product ID, we create an entry for the transaction product. We finally return a JSON response with the transaction ID that we created, as well as an HTTP status code of 200. The problem with this approach is that the controller knows and does everything. For example, it knows the database table names. It shouldn't even know the transactions are stored in a database. For all it cares, the transaction could be stored in a flat file. Inevitably, this approach leads to gigantic and unwieldy controllers of several thousand lines of code. So who should be aware of what? Who should care about the payment gateway credentials? The HTTP client is the only one who communicates with the payment gateway, so that should go here. Who cares about the PDF page size? Well, that's for the PDF library. Who should be aware of the data storage mechanism? That's the database. SMTP configuration? That's for the mailer. The database would never need to know or care about the SMTP configuration. One of the purposes of the single responsibility principle is to hide data from classes who should not be concerned by it. We now need to find class names to encapsulate these concerns. Whoever's in charge of the data storage can perhaps be called data repository. But wait, will that class take care of storing and retrieving any object in our system? What if we want user accounts to be managed using LDAP? No, let's call this class transaction repository instead, so that it would be specific to transactions. Note that the name repository does not suggest any specific type of storage. That technical decision is entirely up to this class now. The next one is easy because its only job is to communicate with the payment gateway. We'll call it payment client, which is a standard name to give something that consumes an API. Again, we don't make any assumptions about what kind of API it is, so the word HTTP is not in the name. Next up is PDF. The receipt might not even be a PDF in the future. It can just be part of the email body. All we know for sure is that we want to email a receipt, so we let a receipt mailer handle that decision. Should it choose to use an attachment, it will use a class called receiptFile, which in turn will decide on the file format. Now let's see what it looks like in the code. The first thing we'll do is change the services to the ones that we identified based on responsibilities. We now have a transaction repository, a payment client, and a receipt mailer. The original services were moved to these new classes. The create method also needs to change. Instead of writing directly to various tables, we add to the transaction repository. Instead of passing an array to this method, we create a transaction object. One of the reasons for this choice is to let us control the amount of information that we share with the transaction repository, because it might not be concerned with some of the content of the data array. This kind of class is called a value object, and you can learn more on the subject from my other video. Moving on to the charge method. We get the transaction object from the repository by providing a transaction ID. We then convert that transaction into a payment object. Again, we're controlling the amount of information that we pass to the payment client. That class should not concern itself with things like products. It should only care about the amount to charge and to what credit card to charge it. Now onto the email receipt method. Once more, we get a transaction from the repository. We then convert it to a receipt object. It will hold only the data that we'll need for a receipt and nothing more. The refund method follows a similar flow. We convert the transaction to a payment object, which is then passed to the payment client's refund method. So does that mean that all a controller does is just send data off to a service? Well, it's more nuanced than that. For example, the controller might want to validate the input and send an appropriate JSON response should the validation fail. It might also want to wrap this statement in a try-catch in case the repository fails to find the transaction. The refund call will probably need to be in a try-catch as well in case the payment gateway rejects a credit card or some other error occurs. The decision as to what response to return based on the various use cases is the controller's responsibility. All other responsibilities have been delegated to other services. Let's summarize the different classes that we created. We have a transaction controller that communicates with a transaction repository, a payment client, and a receipt mailer. The mailer in turn communicates with the receipt file. Note that the payment client is completely unaware of what's going on in the repository. They can't influence each other, which means that making changes is a lot safer. Since all these classes are small and specialized, it would also be easy to read and understand them in order to make a change. The transaction controller's responsibility is to respond to requests. It can do so by forwarding the data received to the various services, who then have their own responsibility. The responsibility of the repository is to store the transactions. The payment client sends requests to the payment gateway. The receipt mailer sends receipts. The mailer attaches a receipt to the email by leveraging the receipt file service, which creates the actual file. As you start separating things into classes, you might make some mistakes. One of them is to make every class do only one task. Single responsibility does not mean single task. A postal service's responsibility is to get the letter into your mailbox. That involves many tasks, such as collecting the letters from their point of origin, sorting them, and putting them into the appropriate mailboxes. You might also put a responsibility in the wrong place. For example, if your receipt needs the products sorted in the order in which they were added to the cart, it would be tempting to add that logic in the repository. However, only the receipt needs things in that order, so that's where you should do the sorting. If you do it in the repository, you might break an admin report where they need products in alphabetical order. If a small change requires you to modify multiple services, you may have split things too much, or split them in the wrong place. Here's a way to visualize it. Let's say that these are various tasks in 3 different classes. Each time you want to make a tiny change to the receipt's layout, you need to edit all 3 classes. Because all of these tasks are so closely related, they should be in the same class, either one of those 3 classes or a completely new one. This is a much better segmentation. Now, a developer only has to read one class to understand the layout and doesn't risk introducing unintended consequences outside of that class. That developer will also not block everyone else, because everyone can work safely in their own little class. Another problem you might encounter is having unnecessary back and forth between 2 classes. In this piece of code, the mail client gives us things that we just pass back to it. Why did we need to care about the configuration or the transport? Why couldn't we just give the mail client a message object? The mail client already has access to the configuration and transport. It should have just used its private properties and not even exposed the get methods. I often see classes that do too much, and they typically end with manager, service, processor, or util. It's an easy way to throw a whole bunch of loosely related responsibilities into one class. What does the manager do? What does it mean to manage? It could be anything. For me, that's generally a code smell. You gain many advantages from properly separating responsibilities and concerns in your application. In a project that I built in 2013, it took me 5 minutes to make a change requested by the client. In most applications with which I work today, a similar change can take days or even weeks. Since each change is generally confined to one class, it's much easier to have developers work simultaneously on different things. It's also much easier to start working on one class, like the payment client, even if we haven't finished making all the decisions for the receipts. Each class has limited responsibilities and makes its own decisions about those responsibilities. Because of that separation, you need to read less code to understand how something works. It's easier to make a mental model when you deal with less code at once. And that's it for this video. I hope you have a better idea of how to apply this principle in your code. This is part of a video series on all 5 solid principles, so make sure to check the rest of the channel. Thank you for watching and happy coding!